technology is not merely an innovation. It is humanity's commitment to future generations, where intelligence, energy, and communication coexist in harmony with nature. This conference, themed Green AI, Green Communication, and Green Energy, provides a global platform that brings together academicians, industry leaders, researchers to explore technological solutions that empower sustainable development. Respected Director, Registrar, esteemed Chief Guest, Guest of Honor, IEEE representatives, distinguished keynote speakers, deans, HODs, faculty members, researchers from academia and industries, participants, and dear students, a very pleasant morning to one and all present over here. On behalf of the Department of Computer Science and Engineering, Electronics and Communication Engineering, and Electrical and Electronics Engineering of National Institute of Technology, Puducherry, I, Noore Mariam,
and I am Sailaja. We welcome you all to the IEEE technically co-sponsored 3rd International Conference on Signal Processing, Computation, Electronics, Power and Telecommunication. In short, iConSCEPT 2025.
Culture is the foundation upon which knowledge stands tall. I request everyone to kindly rise for the Tamil Thai Vartha.
வாழ்வினில் செம்மையை செய்பவள் நீயே, மாண்புகள் நீயே, என் தமிழ் தாயே, வீழ்வாறு வீழாது காப்பவள் நீயே, வீரனின் வீரமும் வெற்றியும் நீயே, தாண்டிடு நிலையினில் உனை விடுப்பேனோ, தமிழ் என் நாளும் தலை குனிவேனோ, சூழ்ந்தின்பம் நல்கிடும் பைந்தமிழன்னாய் தோன்றுடல் நீ உயிர் நான் மறப்பேனோ, செந்தமிழே உயிரே நறுந்தேனே, செயலினை மூச்சினை உனக்களித்தேனே, நைந்தாயனில் நைந்து போகுமென் வாழ்வு, நன்னிலை உனக்கெனில் எனக்கும் தானே, முந்திய நாளினில் அறிவுமில்லாது மொய்த்தனன் மனிதராம் புதுப்புனல் மீது செந்தாமரை காடு பூத்தது போல செழித்த என் தமிழே ஒளியே வாழி, செழித்த என் தமிழே ஒளியே வாழி, செழித்த என் தமிழே ஒளியே வாழி.
Thank you all. Please be seated. Just as a single flame dispels darkness, enlightened minds illuminate the future of sustainable technology. Light symbolizes knowledge, clarity, and hope. To signify the auspicious beginning of iConSCEPT 2025, I now request the dignitaries to come forward for the lamp lighting ceremony.
In the era of intelligent systems, the greatest intelligence is sustainability. This thought reminds us that true progress lies not only in advancing technology, but in ensuring that such advancement remain responsible, ethical, and beneficial to society at large. With this spirit, it is my privilege to welcome the convener of iConSCEPT 2025 and head of the Department of Computer Science and Engineering, Dr. Venkatesan M., who has consistently fostered a culture of academic excellence, research innovation, and collaborative growth within the department as well as in our institution. His guidance and commitment have played a pivotal role in organizing this international conference to a fruition. So please.
வணக்கம், குட் மார்னிங், நமஸ்கார். அன்புடன் வரவேற்கின்றோம் அறிவின் சங்கமத்திற்கு. We welcome you with love to this confluence of knowledge. I begin with a beautiful திருக்குறள் by திருவள்ளுவர். முகம் மலர்ந்து விருந்தோம்பல் முக்கியமாம், அகம் மலர்ந்து நோக்கல் அதற்கு மேல்தாம். I'll translate in English. To welcome a guest with a smiling face is important. To welcome them with smiling heart is even greater. Respected Director, Registrar, Chief Guest, distinguished guest, dignitaries in the dais, deans, HODs, esteemed faculty members, researchers, participants, and dear students, it gives me immense pleasure to extend my warm and heartfelt welcome to each one of you to International Conference on Signal Processing, Computation, Electronics, Power and Telecommunication, iConSCEPT 2025, organized by Department of Computer Science Engineering, Electronics and Communication Engineering, and Electrical and Electronics Engineering, National Institute of Technology, Puducherry. Over the next 2 days, we will engage in focused deliberations on the conference theme, Green AI, Green Communication, and Green Energy. In an era marked by rapid technological progress and an urgent global commitment to sustainability, this theme highlights the critical need for efficient and environmentally responsible solution across computing, communication system, and energy technologies. We look forward to insightful discussions, meaningful collaborations, and innovative ideas that will contribute to shaping the future of sustainable technological development. iConSCEPT 2025 received 1120 paper submissions from researchers worldwide, of which 320 papers were accepted for presentation, resulting in an acceptance rate of approximately 28%. Among the accepted authors, 120 will attend the conference in person, while the remaining participants will present and attend virtually. We are truly privileged to have the gracious presence of our distinguished guests for this inaugural function. We extend a very welcome to our visionary leader, Dr. Makran Madhav Gangrekar, Director, National Institute of Technology, Puducherry, who is presiding over this function. His unwavering commitment to research-driven development has been a significant catalyst in advancing the Institute academic and research excellence. As Dr. APJ Abdul Kalam aptly stated, excellence is a continuous process, not an accident. Dr. Gangrekar truly exemplifies this philosophy, inspiring the entire academic community to pursue sustained excellence, foster meaningful research, and continually elevate the institute standards through dedicated effort and quality outcomes. Sir, we are honored by your gracious presence with us today. It's my great honor to extend warm welcome to Dr. S. Sundaravardhan, esteemed Registrar of the National Institute of Technology, Puducherry. Arise, awake, and stop, not till the goal is reached, said by Swami Vivekananda. Your exemplary work, ethic, and dedication to institutional growth truly reflect the spirit of this inspiring quotation. We are sincerely grateful for the unwavering commitment and administrative strength and guidance you provide, which transform ambitious ideas into successful realities. Sir, we are honored by your presence. It is a privilege and immense honor to welcome our chief guest, Professor Alejandro Ferre, Professor, Victoria University of Wellington, New Zealand. Professor Ferre is globally recognized for his excellence in statistics and data science, particularly for his pioneering contributions to understanding the crucial role of statistics and data science in remote sensing applications. Despite unexpected flight disruptions yesterday, the professor was unable to travel from Mumbai to Karaikal as planned. Even so, he showed a great dedication by journeying overnight by car from Bangalore to Karaikal. We sincerely thank him for his interest in being part of iConSCEPT 2025 and for making the long journey from New Zealand to Karaikal. Thank you, sir. Your dedication to pursuit of knowledge remind us for the profound truth in Mahatma Gandhiji words. The best way to find yourself is to lose yourself in the service of others. Your service to the global academic community through your research and teaching is truly inspiring. Thank you, sir, for being here. It is my distinct pleasure and honor to welcome our guest of honor, Dr. Arun Kumar Sangaya, Professor, National Union University of Science and Technology, Taiwan. Dr. Sangaya is not only highly distinguished academician, but also a valued colleague and trusted friend to me and to our department. His dedication to mentoring young researchers is truly commendable. As a globally recognized researcher, he has generously supported 2 of our students through research internship in Taiwan, providing them with invaluable international exposures. He has also extended his support in the submission of an Indo-Taiwan joint project proposal this year, for which we are currently awaiting the outcome. These efforts strongly reflect his commitment to fostering academic growth beyond institutional boundaries. We are delighted that Dr. Sangaya is willing to further strengthen this collaboration through a formal memorandum of understanding with our institute. Sir, we sincerely thank you for your constant encouragement and collaboration. We are truly honored by your presence with us today. It's my privilege to acknowledge and extend my sincere appreciation to the IEEE Madras Section Chairman, Dr. Shaktivel, and the entire team for their invaluable support towards iConSCEPT 2025. Unfortunately, due to their busy schedules and unforeseen circumstances, they are unable to be with us in person today. Nevertheless, we are deeply grateful for their continuous guidance, encouragement, and support. It's my pleasure to welcome our faculty member and IEEE Counselor of NIT Puducherry, Dr. A. Vengadeshan. You have been the driving force behind many successful IEEE initiatives at our institute. Your dedication to organizing technical and professional development activities is truly commendable. These efforts have created valuable learning and networking opportunities for our students. We are delighted to have you with us at iConSCEPT 2025, sir. Welcome, sir. It's my distinct pleasure to warmly welcome Dr. Anirudh Kani, instead of our Dean Dr. Magabatra, Associate Dean Research and Consultancy, NIT Puducherry. Sir, we are sincerely grateful for your constant support and valuable guidance throughout the planning and execution of iConSCEPT 2025. Your encouragement has been instrumental in the smooth and successful organization of this international conference. We are truly honored by your presence with us. It's my great pleasure to warmly welcome the deans, head of the departments, associate deans, chief warden, chairperson of various committees, faculty members of different departments, and the non-teaching staff of various sections of NIT Puducherry. Your presence adds immense value and dignity to this occasion. We warmly welcome the research community attending iConSCEPT 2025, both those who have traveled from various parts of India to join us in person, and those participating virtually from different locations. We sincerely appreciate the time, effort, and enthusiasm you have invested to be part of this conference. I warmly welcome the research scholars. They are the backbone of our department and other department, PG and UG students of our department and other department. Your energy, dedication, and active participation are the backbone of iConSCEPT 2025. I warmly welcome the press, media representative, and all other individuals who are directly or indirectly associated with the successful organization of this conference. Once again, on behalf of the organizing committee, I extend a warm welcome to all of you to iConSCEPT 2025. We wish this conference great success and fruitful discussion. Thank you.
For your gracious and inspiring welcome, your words have set a thoughtful and honor is the simplest way to express our gratitude. With this note, I request our director, Dr. Makarand Madhav Gangrekar, to felicitate our chief guest, Dr. Alejandro C. Freire, professor at Victoria University of Wellington, New Zealand. Thank you, sir. Now, I request our Registrar, Dr. Sundaravardhan S., to felicitate our guest of honor, Dr. Arun Kumar Sangaya, Professor at National Yunlin University of Science and Technology, Taiwan. Thank you, sir. Now, I request our convener of iConCEPT 2025, Dr. Venkateshan M., to felicitate our director, Dr. Makran Madhav Gangrekar. Thank you, sir. Now, I request our co-convener of iConCEPT 2025, Dr. Anshuman Mahapatra, to felicitate our registrar, Dr. Sundaravardhan S. Thank you, sir. Now, I request Head of the Department of Electrical and Electronics Engineering, Dr. Vino Prabhati, to felicitate our Dean of Research and Consultancy, Dr. G.S. Mahapatra. Sir is unfortunately not available today. However, he has conveyed his well wishes, and on his behalf, our Associate Dean of Research and Consultancy, Dr. Anirudh Kandye, is here to grace us with his presence. Thank you, sir. Thank you, ma'am. Now, I request Head of the Department of Electronics and Communication Engineering, Dr. Bhupati Rani R., to felicitate our IEEE Counselor of NIT Puducherry, Dr. Venkateshan Arunachalam. Thank you, sir. Thank you, ma'am. I request all the dignitaries to be seated. Excellence happens not by accident, it is a process. These words of Dr. APJ Abdul Kalam reminds us that sustained progress emerges from consistent dedication, clear vision, and purposeful action. It is in this spirit that we look to the leadership of our director, Dr. Makran Madhav Gangrekar, a distinguished academician, an inspiring visionary who continually motivates us to aspire higher, achieve more, and contribute meaningfully to our institution, society, and the nation. His guidance has been instrumental in fostering a culture of innovation, academic rigor, and societal responsibility at National Institute of Technology, Puducherry. Ladies and gentlemen, it is my honor to invite our respected director, Dr. Makran Madhav Gangrekar, to kindly deliver the presidential address of iConCEPT 2025. Sir, please.
honorable guest, Professor Freri, Professor Sangaiya, my other faculty colleagues, organizer of this event, faculty colleagues sitting off the dais, the deans, the student members, and other participants coming from other institutions. Very warm welcome to all of you to the NIT Puducherry, and very good morning. It's an honor to inaugurate this conference, though this is not my subject, but the landscape of engineering education is changing because of this enhancement in the communication. The knowledge contribution is enhancing day by day, and it is very apt time, and I congratulate the organizer for considering this theme for this the international conference. I congratulate all the organizers for holding this international event at NIT Puducherry. And also thank all the participants. I mean, as Dr. Venkatesan has said, I mean, more than 300 articles have been selected for a presentation. Half of that online, half of that typically is offline. And thank you those who are coming offline. Also thanks to those who are unable to come here at NIT Puducherry but agreed to present your research in the online mode. The signal processing and computation, electronics, power and telecommunication, I mean, it has immense application in various branches of engineering, including the automotive sector, whether a driverless car driving, even medical sciences, even forensic investigations, and many other areas. I mean, no engineering area can remain untouched in this domain. And the presentations that you will have in this next 2 days definitely will enhance your knowledge and help the young engineers, particularly young scientists who are working here, young researchers who are attending here this conference. So you will have exposure to this knowledge. You will have opportunity to interact with the peers as well as the professionals as well as your seniors. And I hope you will have really wonderful sessions. You will enjoy academically. The discussions that will happen here will stimulate you to do more and more research for contribution, for research contribution and developing or furthering knowledge in this domain. I wish all of you a very wonderful stay at those who are staying on campus or off the campus, very wonderful stay at the Karaikal, and I'm sure our faculty members and organizing team members will ensure that your stay will be very comfortable in the Karaikal for whatever duration that you are planning. So thank you once again for coming over here, and thank you particularly the international visitors, our chief guest, for taking all the trouble in spite of the disturbances in the flight schedule. I mean, thank that you could reach on time for inauguration, but really, as Professor Venkatesan has said, your dedication and devotion, really we appreciate. I mean, whole night you are traveling and still sitting in front of us and witnessing this event. It's really something that we all have to learn. I mean, the age doesn't matter. It's a devotion and dedication within that makes it happen. And I'm very happy and glad that you are here to witness this inaugural sessions. So thank you all of you once again, and wish you all a very wonderful interaction, a very fruitful interaction socially as well as academically. Jai Hind.
Thank you, sir, for your insightful and inspiring presidential address. Your forward-looking vision has set the right tone for this conference, guiding us towards meaningful academic engagement and encouraging us to contribute with purpose and excellence to the scientific community. Thank you, sir.
Innovation is the key driver for inclusive growth, remarked Dr. R.A. Mashalkar, reminding us that progress flourishes when systems support people and enable them to move forward together. These words reflect the spirit of commitment, service, and responsibility that strengthens institutions and enable progress. In our campus community, this spirit is exemplified by our esteemed registrar, Dr. Sundarvardhan S., a highly supportive and dedicated administrator who ensures that every query, concern, and requirement is addressed with speed, clarity, patience, and absolute commitment. His readiness to assist and his ability to provide solutions with efficiency make him an indispensable force in the smooth functioning of National Institute of Technology. Ladies and gentlemen, it is my honor to invite our respected registrar to deliver the to address the gathering. So please.
Respected Director, Honorable Chief Guest, Guest of Honor, colleagues and participants from across the country. Welcome you all to NIT Puducherry and a warm good morning to one and all. The organizing team, Dr. Inauguration and his department, along with EEE and ECE, which is organizing this iConSCEPT for the next 2 days, have chosen the words and have given a very good welcome address and have felicitated all the guests. And indeed, I don't know whether I deserve whatever he has told, but still, thank you. And this shows itself that how the organizing members on the team have very, very well planned, and definitely all the participants will benefit, will enjoy it. And with respect to the chief guest, as rightly pointed out by Director and Venkatesan, he just reached in the morning by 8:45 and he is straight away here. Thank you, sir, with all the pain that you have taken. And Dr. Sangaya is visiting our institute for the second time. Thank you, sir, for your support and encouragement. And for the information of the participants, our institute has produced 3 semiconductor chips, which was distributed by among the 100 chips. It was by Ashwini Vaishnav, Minister of Electronics, and Dr. Anil Kane has received it just a week back. This is for the information. And in fact, all the departments, all the faculties are working hard in bringing up many laurels to this institute. And I should also appreciate all the research scholars who are behind the scene and publishing many papers, and wish all the participants would definitely benefit by this brainstorming session, and have a wonderful day here. Thank you.
Thank you, sir, for your thoughtful and encouraging address. A conference becomes a legacy when the ideas are documented. Now, for the most awaited part of today's program, I request all the dignitaries on the dais to release the iConSCEPT 2025 conference proceedings.
Thank you all. I request all the dignitaries to be seated. There is no ambiguity of purpose when science serves the nation. Dr. Vikram Sarabhai's word underscored the clarity and direction that science provides when it is pursued with dedication and responsibility. In this spirit, we are truly honored to welcome a scholar whose work embodies precision, depth, and global impact. With this, I now request Dr. Sanjay Bankapur, Assistant Professor, Department of Computer Science and Engineering, to introduce our chief guest, Professor Dr. Alejandro C. Freire. Sir, please.
It is my great honor to introduce our chief guest, Professor Dr. Alejandro C. Freire, an internationally respected scholar in computational statistics and image processing. He is a professor in statistics and data science at the School of Mathematics and Statistics, Victoria University of Wellington, New Zealand. Professor Freire completed his BSc in Electronic and Electrical Engineering from the Universidad de Mendoza, Argentina in 1985. He earned his MSc in Applied Mathematics Statistics from the Instituto de Matemática Pura y Aplicada, Rio de Janeiro, Brazil in 1990, and later obtained his PhD in Applied Computing from the Institute Nacional de Pesquisas Espaciais, San Jose do Campos, Brazil in 1993. With an academic career spanning several decades, he has authored around 400 research publications and made influential contributions to computational statistics, stochastical modeling, and remote sensing image analysis, particularly in the statistical modeling of synthetic aperture radar and polarimetric synthetic aperture radar imagery. Over the last 5 years, he also contributed to several funded research projects reflecting this continued dedication to impactful research and innovation. Beyond his research accomplishments, Professor Freire has held major leadership roles in the global research community, serving as editor-in-chief of IEEE Geoscience and Remote Sensing Letters, as a distinguished lecturer for IEEE Geoscience and Remote Sensing Society, and currently as a vice president for publications of IEEE Geoscience and Remote Sensing Society. Before joining Victoria University of Wellington, he was a full professor at the Universidade Federal de Alagoas, Brazil, and held the prestigious Haoshan Scholar position at Xi'an University, China, demonstrating his strong international presence and collaborations. Professor Freire stands as an exemplary academic leader whose research excellence and global contributions have significantly shaped the fields of data science and remote sensing. We are truly honored to welcome him as our chief guest for this international conference, iConSCEPT 2025. I now invite Professor Freire to address the gathering. Please, sir.
Very kind of you, but you could have omitted the years. Yeah, okay, because yeah, I'm old. Do you know what this means? You know what this is? This is the difference between us here now and the prehistory, because this is memory. Memory is what makes us human. So, yeah, cherish this. Okay, thank you very much. So, starting. I never prepare speeches, so you will notice that. I haven't slept for 2 days, so worse. So, Professor Gangrekar and Professor Venkar Metesan, I salute you and in your name, the name of everybody here. I would like to say a few words about who's sponsored partially this, because I emphasize partially. When people say sponsor, you may imagine that here comes a truck full of dollars and millions of dollars. It's a small amount of money, the sponsorship. But then I will go back to the who's doing this. So this IEEE is the International Electronics and Electrical Engineers Society. It's the largest technical scientific society in the world. It has roughly 500,000 members. It's organized in societies, and I belong to one of them. So one of these societies, a mid-sized society, the Geoscience and Remote Sensing Society. We are 8,000 members. And I want to use two thoughts. One of these thoughts is how a past president and good friend of mine, Professor Paolo Gamba, how he defined the society. He said, our society is a community of communities. And our current president, Professor Simon Tuata, he says in his vision, his presidency is for enhancing how we serve our members. So serving our members is serving a community of communities. There are several ways in which we try to serve our members. Courses, material online, publications, and that's a big thing for me because I am the vice president for publications. But publications and conferences and events. And this brings, so let's pinpoint a couple of things: communities, serving, conferences. Let's try to put these things together. This is a conference. This is a scientific conference. And this is serving a community. Which community? You. And you are a community of communities. Think, for instance, seasoned researchers, and he made me a favor of saying, how old am I? I'm 65. Not so seasoned researchers, young researchers. So seasoned researchers, a community. Younger researchers, another community. Students, another community. They are not disjoint, right? They are not disjoint. Younger people, I see 2 kids, wonderful, the future is here also. Now let's gather this community by, for instance, research interests. I do statistical computing, boring, no, I love it, it's fantastic. And you will see it in my talk. But there's lots of people who do artificial intelligence, and there's people who do basic research, communities. And there's also communities by gender, the infinitely many genders that are around, and by nationality and by professional experience, but there are infinitely many communities, and we make part of several of them. So a conference is serving these communities. We are here for that. And I will conclude with a challenge, because I always propose challenges to my students and my colleagues. This challenge is for students. How do you measure the success of a conference? For you, students, you can measure it by counting how many seasoned researchers you talk to. It's not enough to see some of us here or drinking tea. You will see me drinking tea a lot. I love tea. It's not enough. Come, talk to us. Students, how many young researchers have you met? New young researchers. How many new students you have talked to? Do not stay in the bubble. You are part of several communities. Interact with them. So, and finally, how many different topics you've heard about? Again, break the bubble. Do not stay listening to what you know, to what you already know. Take a step outside the bubble. Be exposed to different things, new ideas. That is how we make good science. And we're here to make good science. Why? Because science is what makes us different from the amoebas or the bacteria or whatever is out there. So let's do good science. Thank you very much. And also, before I end, do you have any idea of how many people is behind the scenes supporting this? So I ask you a big round of applause to those invisible people, or not so invisible, but those nameless people who are making this happen. So thank you very much, and have a great event. Thanks a lot.
Thank you, sir, for your kind, inspiring, and enlightening words. Your perspective have added immense value to this conference and will resonate with our academic community. Thank you, sir. Let us hold our heads high, for the highest wisdom belongs to those who serve humanity. These words of Tagore remind us that true wisdom lies in contributing to the world through knowledge, research, and service. It is this spirit of purposeful scholarship that is exemplified by our distinguished guest of honor. I now invite Dr. Vani V, Associate Dean Student Welfare and Assistant Professor, Department of Computer Science and Engineering, to introduce our guest of honor, Professor Dr. Arun Kumar Sangaya. Ma'am, please.
Good day to one and all on the dais and off the dais. It's my pleasure to introduce our guest of honor, Professor Arun Kumar Sangaya. He is a distinguished professor at International Graduate School of Artificial Intelligence, National Union University of Science and Technology, Taiwan. He holds a PhD degree in Computer Science Engineering from Vellore Institute of Technology, Vellore. Professor Sangaya has over 2 decades of academic and research experience undertaking the roles from lecturer to professor at VIT University before joining UNTEC in 2022. His research spans a broad spectrum of topics including AI, IoT, sustainable computing, neural networks, viral sensor networks, embedded systems, cloud computing, and related areas in software engineering systems. He is widely recognized for substantial scholarly output, more than 300 research articles in refereed journals, many edited books, and many filed patents. In recognition of his contributions, he has been named a highly cited researcher by Clarivate in 2021, 2022, and 2023. He is also recipient of Yushan Young Scholar Award, awarded by Taiwan Ministry of Education, among other distinctions. Beyond research, Professor Sangaya plays an important role in scholarly publishing. He serves as editor-in-chief for multiple book series, to be noted, Sustainable Computing, EDGI, and as editor or associate editor for several reputed international journals. He had also been a visiting scientist at Chinese Academy of Sciences, China, and a visiting researcher at University of Paris, France, demonstrating his global collaborations. Overall, Professor Sangaya brings to the conference deep expertise in AI, IoT, sustainable computing, and related emerging technologies, a strong track record of research and publications, a global academic expertise and leadership in academic publishing, making him an eminent figure in the fields of computer science and intelligent systems. I now invite Professor Sangaya to share his thoughts with us. Welcome, sir.
Respected Director, Honorable Registrar, and Chief Guest, and other delegates on the dais, participants from all around India and across world. A very good morning to all of you. It is truly a privilege to join with you as a guest of honor and keynote speaker for iConSCEPT. I sincerely thank the organizing committee is inviting me and giving me the opportunity to share this special occasion. I hope this conference will bring a lot of bright minds and fascinate to the individuals who can share their valuable experiences on the across computer science and electrical engineering field. As our general chair of the conference has pointed out, more than 1,000 paper was received. Out of 1,000 papers, 300 papers has been shortlisted. It really shows the high impact of this conference. I sincerely request the conference committee to organize this level of conference and elevate this conference in a next higher level. You know, in India, like the importance of the conferences are very less. I expect, this kind of point you have to consider to take a momentum of this conference in a next higher level. I'm also pleased to share, I moved to Taiwan. At the same time, we are doing a lot of Indo-Taiwan projects in the area of AI and IoT and other areas. Right now, our joint project collaborated with the IIT BHU. At the same time, my connections with the NIT Puducherry, it's quite long. We are also applied some of the joint projects. I also hosted NIT Puducherry students in Taiwan. We created a high-equipped AI lab in Taiwan. So please give your continuous support to my lab and sending the students, and it's good opportunity to share our mutual growth. I sincerely request to the director for strengthening our commitment and international cooperation. Request the director to accept the memorandum of understanding with my university it will create again strengthening cooperation in between the institutes in terms of student exchange and faculty exchange, other activities. I sincerely request for your kind consideration to signing of MOU with the Taiwan, my national university. Once again, I thank for the conference committee and organizers who have invited me to grace this occasion. And the special thanks to the conference organizer who has put a lot of efforts to make this conference a grand success. And my best wishes for all the participants who want to share their potential and research capability in the various aspects of the computer science and across the areas. Thank you once again, and have a good day to everyone. Have the continuous 2 days, hopefully, have more technical knowledge to be shared among the peoples. Thank you so much.
Thank you, sir, for your profound and insightful address. Let us remember with gratitude those who guide us, for they hold the lamp that lights our way. These words of Chanakya remind us that every successful endeavor is shaped by the guidance, support, and collective efforts of many individuals. With this spirit, it is now my honor to invite co-convener of iConSCEPT 2025, Dr. Anshuman Mahapatra, to deliver the word of thanks. So please.
Some moments don't just pass, they stay with us, shaping who we become. And today is one such moment. A very warm and grateful good morning to everyone gathered here for the inaugural ceremony of iConSCEPT 2025. As I stand before this august gathering, my heart is filled with immense gratitude for the presence, your energy, and the collective passion you bring to this conference. Today we begin not just an event, but a journey. A journey towards green AI, green communication, and green energy. A journey towards a future that is not only intelligent, but also sustainable, responsible, and accessible. First and foremost, on behalf of the organizing committee, I extend my heartfelt gratitude to our chief guest, Professor Dr. Alejandro Freire, Victoria University of Wellington, New Zealand, and Dr. Arun Kumar Sangaya, National Yun Lin University of Science and Technology, Taiwan, for gracing this inauguration function with their presence by traveling across borders and time zones to be with us. Thank you, sir. To the keynote speakers who will enlighten us over the next 2 days, we look forward to your insightful sessions that will enrich our knowledge. Your participation has truly elevated the spirit of this conference. My sincere thanks to our special guests and those who are not able to make it to the conference from IEEE members. I sincerely thank them for their support for co-sponsoring this conference. Our sincere and heartfelt thanks to our director, Dr. Makarand Madhav Gangrekar sir, for presiding our today's function. Sir, your vision continues to inspire us to dream bigger and work harder. We are deeply grateful to our registrar, Dr. S. Sundaravaradan, for his steady support and goodwill that strengthen our initiative at NIT Puducherry. A special word of thanks to Dr. J.S. Mahapatra sir, Dean Research and Consultancy, for his support for fostering research-driven initiative across the campus. In his absence, I must thank Dr. Anirudh Kane sir, Associate Dean Research and Consultancy, for his presence for the inaugural ceremony. I also express my heartfelt gratitude to my co-chair, Dr. Venkatesan M., General Chair, Head of the Department of CSE, whose leadership has been instrumental in steering this conference with clarity and purpose. I must thank all the faculty and staff of our allied Department of Electrical and Electronics Engineering, Electronics and Communication Engineering, for their constant support for smoothly organizing this large-scale international conference. I offer my heartfelt Appreciation to IEEE Madras section for technically co-sponsored, as well as our sponsor, Micropoint Computer Private Limited, for standing with us and helping us with bringing this vision to life. To our dedicated deans, head of the departments, associate deans, faculty members, hard-working student volunteers, the technical team, and especially our research scholars who worked tirelessly day and night, your effort is the invisible thread that held this entire event together. We see you, we appreciate you, and we thank you. Finally, to the delegates, researchers, and participants from around the world, your presence turns this conference into a vibrant community of ideas. Thank you for choosing to spend your valuable time at NIT Puducherry as well as online. We wish you will be here for the next conference next year, and for believing in this platform and for enriching it with your wisdom. As we step into the next 2 days of knowledge, culture, and collaboration, let us remember, conferences ends, session concludes, but ideas have wings, and the ideas we exchange here may inspire the innovations that future generations rely on. Let us carry forward not just the information we receive, but the emotion, the purpose, and the responsibility that this event stands for. Once again, from the depth of my heart, thank you for making this inaugural ceremony a grand success, truly unforgettable. Wishing everyone an inspiring, meaningful iConSCEPT 2025. Thank you. Jai Hind.
Thank you, sir, for your thoughtful expression of gratitude. Now that we have reached the end of this inaugural ceremony, I request all of you to stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. Please be seated.
On behalf of National Institute of Technology, Puducherry, I wholeheartedly thank you all for joining us in the inaugural ceremony of IEEE Technically Co-Sponsored 3rd International Conference on Signal Processing, Computation, Electronics, Power and Telecommunication, iConSCEPT 2025. Thank you once again and have a great day ahead.
There's a quick announcement. So we'll be having a 15 minutes break, and please reassemble here for the keynote speaker session. And you can have your refreshments outside the auditorium. Thank you. போதுமா?
Good afternoon to everyone present here. It is our great honor and privilege to introduce today's distinguished speaker, Professor Alejandro C. Freire, a globally renowned expert in the fields of statistical computing, signal processing, and image processing. Professor Freire is currently serving as a professor of statistics and data science at Victoria University of Wellington, New Zealand. He holds a PhD in applied computing from the Brazilian Institute for Space Research and has made remarkable contributions to synthetic aperture radar and polyarometric data analysis. His academic journey includes postdoctoral research at IMPA and the Chinese Academy of Sciences, and he has held esteemed positions such as the Vice Chancellor for Research and Innovation at the Federal University of Alagoas and the prestigious Houchen Scholar title at Zhejiang University, China. Professor Freire is a fellow of IEEE, recognized for his outstanding work in the statistical analysis of signals and images. He served as the editor-in-chief of the IEEE Geoscience and Remote Sensing Letters from 2014 to 2018 and currently holds the position of Vice President of Publications in the IEEE Geoscience and Remote Sensing Society. His dedication to research and teaching is evident in his nearly 500 publications and leadership of LECON, a renowned lab for scientific computing. Today, he will be delivering an insightful talk titled The Entropy as a Measure of Texture in SAR Imagery, where he will share a semi-parametric approach to texture analysis in SAR data using entropy measures and statistical testing. Please join me in warmly welcoming Professor Alejandro C. Freire to deliver this talk. Welcome, sir.
Thank you very much for this kind introduction. I'm sorry it doesn't look as good as it should, but okay, it's a little bit stretched, but you will understand. This conference is about green artificial intelligence, green communications, and green energy. So I want to hear from the students which is the greenest computational platform that we have. Any guess? No? Again, for students, which is the sexiest organ in the human body? The same, the brain. So the greenest computational platform that we have is the brain. It's also the sexiest organ in the human body for most of us. And this talk is an example of the use of this sexiest organ in the human body for solving a problem. So first I will mention what is a SAR image. A SAR image is an image generated with microwaves from an airplane or from space. We're talking about easily at 700 kilometers height. These sensors have the ability to penetrate through clouds. So a SAR image doesn't show clouds. They also penetrate through the canopy of trees, so we can see the soil beneath the trees, and they operate by night. The acronym SAR is for Synthetic Aperture Radar. It's a specialty in remote sensing. What I will discuss here, what I will present, is also valid for every type of imaging that uses coherent light or coherent electromagnetic waves. For instance, laser imaging. For instance, ultrasound B. You know, when pregnant people make echograms to see the health of the baby, that's an ultrasound B image. It's noisy. That kind of noise also appears in SAR images, and also in sonar, the sonar of the sea ground. Okay, SAR images are images produced by microwaves in this case, and texture is one of the most important characteristics, but the problem is that we do not agree on the meaning of texture. We have this tactile association, this association of texture with our touch feeling, But in SAR, some people say that the sample is textured when it mixes at least two types of models, two types of observations. Other people say that the sample of the observation is textured when the speckle is not fully developed. Up to this point, you understand nothing. It's okay, because it's a teaser, and I will define the meaning of fully developed speckle. But before that, I need to define what is speckle. What is a speckle? We are using coherent imaging. Our eyes do not use coherent imaging. We measure intensity directly. We measure the intensity of the light, of the reflected light. In SAR and in other types of coherent imaging, we measure the sum of the return signal by each element in the pixel. So technically, our measurement, I don't know if this will work, and you will see, yes it works, but you don't see, but it's okay because I am told. Our measurement S is the sum of M complex measurements. Imagine the following. Imagine that I send an electromagnetic pulse towards you, and I measure what comes back. Each one of you will return a piece of the energy that received, like a mirror. That piece of energy is SL, and also it will return a phase, a different phase. This energy comes in a different phase, because some people are looking at me directly, others are showing the profile. So we have an amplitude SL and a phase phi L for each elementary backscatterer. Backscatterers are the elements in the image that return energy. And what we measure is S, the sum, but it is a complex sum. So this is an example. Here I have 10 elementary backscatterers. The first returns S1. Imagine it could be me. I could be returning this complex number. Complex numbers have a real, an imaginary part. After me comes our photographer. He returns S2, and S1 sums with S2, and then the lady in orange, and then each of you will return a piece, and these pieces sum in a complex plane, in the complex plane. This happened with SAR images, ultrasound images, sonar images, laser images, everything that uses coherent measurement. Finally, what we measure is this red vector. So, this is what we measure, but we want to know what happens in the ground by the observation of S, by the observation of the sum. Okay, so what would, if we knew exactly the properties of every conceivable target, of every environmental condition, of every sensor configuration, if we knew everything about each of you, how each of you reacts to electromagnetic waves, then problem solved, because I could characterize S. That doesn't happen. It doesn't happen in reality. We are far from that. We make hypotheses. We are engineers, at least. And engineers, we make simplifications. When something is very complicated, we start building models that describe a piece of that complex reality. And which are those assumptions? Those assumptions are called fully developed speckle. Remember that S, the sum, is speckle. We call it fully developed if the following conditions hold. Which are those conditions? In the sum, we have infinitely many of you, infinitely many backscatterers. The amplitudes are independent, and there is no giant in the story. Nobody is gigantic. the maximum variance is limited, and they are independent. And the phases, the way that you are looking at the sensor, are independent. And the amplitudes and the phases are also independent. If all this happens, then I can use the central limit theorem. Raise the hand who has heard about the central limit theorem. Come on, engineers. I know you have. Have you taken a course in probability? No? Teachers, they have. Don't. Typical students, you say, do you know how to add 2 plus 2? Come on, don't do that. You know the central limit theorem, right? Have you heard about it? It says that the sum of lots of random things behaves like a normal distribution. That is what we will use. So the fully developed speckle hypothesis allows me to say that the real part, R, and the imaginary part, I, they are normal, independent, identically distributed. I will jump all the technical details. We can discuss that. You can mail me or we can talk in person. If the real and imaginary part are in the normal, independent, identically distributed, then the intensity is the modulus to the square follows an exponential distribution. And I know that you all know what an exponential distribution is. It's this beautiful decaying histogram, an exponential distribution. Okay, look at this. This is a mathematical trick that we will use later. If the intensity follows an exponential distribution with mean mu, it's the same as saying that the intensity follows an exponential with mean 1, and we take mu out of the random variable. Okay, we make it multiplicative, and then we will use that idea. Are you following up to this point? And nobody will answer, so I will continue. Do we observe fully developed speckle in practice? This is a SAR image. You don't see colors. You see intensities. You don't see clouds, because clouds are invisible for SAR. These patches are agricultural areas, different agricultural areas. This is an urban area. That is another urban area, but this image is mostly agricultural. In agricultural parcels, in agricultural areas, yes, we have fully developed speckle. Why? Because SAR works typically in frequencies that range between 3 and 20 centimeters. And in an agricultural parcel, the objects are smaller than this, much smaller. So I have infinitely many of these things. Think of leaves of grass. Think of rice paddies. Infinitely many fit in 20 centimeters. Okay, so the central limit theorem holds we should have fully developed speckle. And look at this. These are the histograms of the real part of a certain of an area with over 15,000 observations. A sample big like this is impossible to fit in general. But in this case, the fit is perfect. And the intensity follows almost perfectly the exponential distribution. So we do see fully developed speckle in practice. But intensity images are very noisy. So what we do is we take the average of, say, L independent images. This is called multi-look. And what is the distribution of the sum of exponential random variables? Sum of independent exponential random variables. And nobody will answer, but it's a gamma distribution. The sum of L independent exponential random variables is a gamma random variable, and we denote it by this. And this is our starting point. we have an image, and we want to check if this area, this particular area, is fully developed speckle. Translated, we want to check if this area is a collection of independent, identically distributed gamma observations. Nice. Okay, that can be done. What are the properties of the gamma distribution? That is the probability density function, easy peasy, you know that. Interesting thing, the coefficient of variation, which is the ratio between the square root of the variance to the mean, doesn't depend on the mean. And that's interesting because I can pick a sample, compute the coefficient of variation. I can pick another totally different sample, compute the coefficient of variation. And if they are from fully developed speckle, they will give me the same number, regardless the mean, regardless the variance. That's an interesting property of the coefficient of variation, and because of that, it is used to check the fully developed speckle hypothesis. Okay, but does it always hold? No, the answer is no. Look at this. We have in the gamma model the same multiplicative property. We can take the mean out. Why do we use this, or why do we mention this? We mention this because what happens when I don't have infinitely many backscatterers? This is another SAR image, no clouds again, beautiful, I love this image. You see, this is mostly urban, except the sea. The sea is the dark part. The rest is urban. How many things fit in a city, fit in 30 times 30 centimeters? If I am looking at a house, one. If I am looking at the forest, I don't know, the number of trunks, a few, very few. So M will not go to infinite, and my fully developed speckle model goes south. How do we model that? We model that making mu, the mean, a random variable. Instead of constant, we make it a random variable. And that works. That is called the multiplicative model. And assumptions, 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 my PhD thesis, we come to this distribution. Nobody will answer, but have you heard about the F test, Fisher-Snedeker test of equality of variances? It's related to this distribution. This was my PhD thesis. I call it the G0 distribution. It may look scary, but it's very, very nice. It doesn't have special functions except the gamma function. It's cool, pretty cool. And the interesting thing is that this new parameter alpha that you see here counts the number of backscatterers. If I have an image, pick a sample, estimate alpha, and alpha says minus is negative, minus 7.2, I know that in that area there are around 7.2 trees per pixel. It is, and we're talking about, we're looking at 600-700 kilometers from space, and I can count the number of trees. So it is amazing. Okay, so let's recap. We have two models, the gamma model and the G0 model. And I want to know which is the best for the data I have. Because if it's gamma, it's pasture, it is bare soil, it is crops. If it is G0, it's urban, it is forest, it is rough sea, it's something different. So we have several ways of doing that, but we want to do it with small samples, samples of size 9, samples of size 15. So that's the kind of thing I do, tough thing, difficult things. Small samples and eventually contaminated. What's the methodology? Statistical approach. So we have a test, statistical test. My null hypothesis, the data are fully developed, speckle, become distributed, the same, or alternative, the data are G-not distributed or non-fully developed spectrum. And this is failing. I will have to stay here. Okay, so those are our two hypotheses. This is called a nested inference situation. It's a very interesting problem in statistics. We have many, many tests for that, but we want one that works with small samples and that also works with contaminated samples. And we want it computationally efficient. Okay, so this is a set of references. I will give you the slides with all the references. So we want to make a hypothesis test, but we want to use information theory. Why? Because we want to use the good properties of the models that we want, that we have, but we don't want to estimate the parameters. That's the trick. We have good models, but we don't want to estimate the parameters. Why? Because the estimators are too unstable. Okay, so what we do, I will skip a little bit because I think I'm being kicked out. What we use? We use the entropy. The entropy has been a long time obsession in my life. It's a concept that I love. I like it very much. We decided to use the entropy. But there are many ways of there are many types of entropy. And why do we use the entropy? Shannon, the father of the concept of entropy in telecommunications, he was looking for a term for this quantity. And he talked to a genius, John von Neumann, and John von Neumann told him, use the word entropy for two reasons. In statistical physics, we use entropy for something which is similar to what you have defined. And the second reason, and the best one, is nobody knows what entropy is. So if you name this thing entropy, half your argument is won. So use entropy, and Shannon used the word entropy. But there are several types of entropy. Imagine that we're working with a continuous random variable whose distribution is characterized by a probability density function f. We have the Shannon entropy. I assume you all have seen the Shannon entropy sometime in your life. It's a fascinating quantity. It measures the disorder of the system. All types of entropy measure the same. Imagine that you have observed a process for a certain time. Your ability to characterize or to guess what comes next is the entropy. Another thing, imagine that I have a cup of red wine, half water. The energy that I use to put the water inside the red wine is relatively small, right? Not much energy. And how much is the energy I would need to split the mixture into wine and water? Huge amount of energy. That difference is also measured by entropy. The entropy is what measures that our universe slowly goes into a useless soup of lukewarm atoms, because the universe is going there. The universe will die, and the entropy measures how far or close we are from that point. Okay, this is the Shannon entropy, but we also have the Rényi entropy, and we also have the star of the night, that is the Salis entropy. Salis, I know this guy. He's Greek-born, Argentinian, raised and now lives in Brazil, physics researcher, and he has been almost nominated to the Nobel Prize several times for this entropy. This entropy is able to measure this decay to the nothingness of the universe. But they are all the same, they are all from the same family. These are all types of entropy. And this is what we will measure. Okay, so we have two models, the gamma model and the G-naught model. Do they have different entropies? The answer is yes. The gamma model has this entropy, this expression. The G0 model has this expression plus something positive. In a nutshell, the Sallis entropy of the G0 model is the Sallis entropy of the gamma model plus something that depends on the texture. And here is our idea. Build a test statistic, pick a sample, check if the entropy, the Sallis entropy, is close to the SAR Sallis entropy, or if it's close to the gamma naught Sallis entropy. It's simple. It's a relatively simple idea. But we want to do it in a smart way. So we want to estimate this entropy under the gamma SAR model or this entropy under the G0 model. But we don't want to compute, we don't want to estimate alpha, so we cannot estimate this. And we do not rely, we do not trust mu, so we cannot estimate this. And this is, I would say, a Gen Z situation. I don't want this and I don't want that, and I will wait for somebody to solve my life. Okay, so how do we break this situation? We use model-free estimation of the Sallis entropy. We use non-parametrics. Notice that we have been doing parametric statistics. Now we move into non-parametric statistics, and we did this with the Shannon entropy, we did this with the Reni entropy, and now this paper, this that I am presenting to you, is we are going to submit next week. This is what we want to estimate. Some relatively basic calculus suggests to use a transformation of variables to solve this integral. This is the recipe that I leave to you to play with. This is not ours. This is not mine. This belongs to my PhD student, Janet Alpala. She did this, she's brilliant, and she rewrote the Sallis entropy, that is this, in this way. See, this is an equality, so she replaced this integral by this integral, in which q prime is the derivative of the quantile function. So we must integrate the derivative of the quantile function to the 1 minus alpha power between 0 and 1, etc., etc. Awful. So this is what we must do. But we don't know how to do it. But we are statisticians, and we are bold. And whenever we don't know a quantity, what do? We put a hat on top of the quantity. We estimate quantities. What do we need to estimate? We need to estimate q prime. In order to estimate q prime, first we estimate q. How? Q is the quantile function. How do we estimate the quantile function? With order statistics. You are all engineers. Come on, wake up, engineers, wake up. If somebody asks you to estimate the derivative, what do you do? Differences, right? Differences. What is the derivative of something? F at t plus delta t minus f at t divided by delta t. A difference. So if we need to estimate the derivative of this, we estimate it by the differences of the estimator of this. The estimator of this are order statistics. The differences are differences of order statistics. We call them spacings. And done. And then how do we approximate an integral? By a sum. Beautiful. This is our result. We wanted to estimate the Sallis entropy of a sample. It will be blah, 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 minus 1 over n, the sum, this replaces the integral, of the estimator of the derivative of the quantile function. and the estimator of the derivative of the quantile function is just differences of order statistics. What is this? I get a sample, I sort it, and then I pick differences of these sorted observations. Do you want anything simpler than that? Really, really simple. Cha-chan, Janet's PhD main result, here it is. This is how we estimate the Sallis entropy. Do we need a model for this? Are we assuming anything? No. So does this work for the normal distribution? Yes. Does this work for the G0? Yes. Does this work for the gamma? Yes. Does this work for the crazy Cauchy distribution? Yes, because it estimates the Sallis entropy regardless the model. It will give you a number, and this number is an estimator of the Sallis entropy, and you don't need to use anything about the model. It converges to the Shannon entropy, which is kind of a universal thing, and just requires sorting and differences. Extremely, extremely simple. And it doesn't suffer from numerical instabilities, which is a curse in my field. We live with numerical instabilities. Okay, but we want more. Yes, we are terrible. We improve this estimator, we improve it with Bootstrap. Bootstrap would be another talk, but it's a resampling technique. Just generating samples from the original sample. And we want more. Remember lambda? Well, we must choose one lambda. We made a study and we found that for our images, 0.85 is optimal. But we want more. We want adaptive windows, and you will see the result. We use an old paper that works very well, and we adapt it. Results. This is the original SAR image over San Francisco. This is sea, this is park, 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 a field of grass, and the rest is urban. Look at my estimator of the Sallis entropy. This is a test statistic. Above, say, 0.1, I do not have evidence for rejecting the null hypothesis. So this is C, this is homogeneous, this doesn't have texture, this doesn't have texture, this doesn't have texture, this is fully developed speckle, grass, C. And when it gets to red, I reject the hypothesis. So I have either forest or urban. It works beautifully. Another image, Munich. See an essentially urban, but urban with different densities. Here is very dense urban area, and these are suburban areas. Look at the colors. It tells me the type of urban area that we have, and it marks where we have sea, where we have crops. Whatever is blue is homogeneous. Dublin, the image I showed you before, the sea and essentially the rest is urban. It detects perfectly, very, very small samples with contamination. And Foggia is also this is the first image I show you. It is essentially crops, so essentially fully developed speckle. You only see red in this urban area, and in the roads that connect the areas. So it works beautifully. Discussion. What do we conclude of this? We presented a statistical approach based on the Sallis entropy to detect texture. The rest is words. We made all these associations, but we want to detect texture. The test uses Bootstrap, adaptive windows, and an optimized parameter. So it's smart, works very well. We validated with simulated images and with true images, and we also use classification. It controls the type 1 error, and it's pretty well with a type 2 error. it is statistically grounded. It tells me the number of things that I have in the ground. It doesn't require label data. Label data, I want to train my neural network, but I don't have label data. What do I do? You don't need that, because the machine that we used is not an artificial neural network. What we use is a natural neural network. We did this on paper and pen, and of course then computational statistics, and it's very fast, extremely fast, because it's essentially sorting and computing differences. Well, it works very well, and you can use it whichever problem you have. Ah, no, I need to work with a crazy distribution called generalized inverse Gaussian. It will work because it does not depend on the model that you need. So it's fantastic. A note, in the two colleagues that kindly introduced me, they mentioned my work on statistics and on SAR, but in the last 5 years I have been working on reproducibility, how to make things that run everywhere, and on replicability, how to do it in such a way that you can improve what I have done. This material, the paper, all the studies, the code, everything is reproducible because, oops, sorry, because I have big fingers. I wrote this in Quarto. Quarto is an extension of R Markdown, which is the markup language. Absolutely amazing, free, fantastic. I embed LaTeX and BBTech. I embed R code, so all the simulations, all the tables, all the figures, everything is produced inside the document. I do not save PDF to input, no. Everything is generated, including the tables. And it's available on a GitHub repository, so if you want to download it, compile it, and submit it on my behalf, I will hate you forever, because I haven't submitted yet, but we will submit it this week. We do, everything we do is like this. We put everything online. If you want to check it, if you want to play, go ahead. Happy to hear your feedback. These are my contacts, and the last slide is the set of references. Well, and you can scan it and contact me if you want. That's it. Thank you very much. I take questions, threats, comments. Yeah, please. I think the battery is dying. Was bad.
Good afternoon, Professor.
Hello.
Myself, Dr. Anita from VIT. I was very happy to see this Salis entropy, which is the generalization of Shannon entropy. As far as the application you have applied here is with the SAR images. So how the Salis entropy fails if the image is of huge noise?
How it faces what, sorry?
Whether it fails if the SAR images are of huge noise.
It works. It doesn't care about the level of noise. Let me navigate. I will show you the expression. Just a second. Do you see L? L is the number of looks. If L equals 1, we have the exponential model, which is the noisiest, the worst signal-to-noise ratio. If L increases, the signal-to-noise ratio improves. You see L here, and you see it here also. So it compensates. The the Salis entropy distinguishes gamma naught from G naught, even in the noisiest case and in the least noisy case. There's a problem of the precision. Where does it estimate the best? Between 1 and 5 is the best estimator. Then it becomes heavily biased, even with bootstrap. But yeah, it works. It works. The others too, Shannon and Rennie, also compensate.
In such case, would you like us to go with any hybridized model with any deep learning technique along with this entropy?
I have a student doing his summer internship working on that, but there are infinitely many things to do about it. For instance, these images that I showed, we use them for visual interpretation, but they can be used as layers for a neural network, a deep learning algorithm for extracting or making classifications. So the answer is yes. Yes, it will be fantastic to see that follow up.
Thank you very much, sir.
My pleasure. Yes, there's another. I'm so happy to see ladies asking questions.
Good
Brave.
afternoon, sir. Good afternoon, sir. Sir, actually I am going on with a paper based on remote sensing images. So how for the SAR technique, how can I apply that in the remote sensing technique?
Wow, tough question.
Remote
You
sensing
cornered me.
images, yes. It actually looks like the remote sensing images which I saw in the data set.
Yes.
So you told that urban images, agriculture, so everything comes under a category of remote sensing
Okay.
data set.
I don't do this usually. I seldom do this, but I will. I will show you my publications on the topic, and I will show you some examples. I worked still a lot with Professor Avik Bhattacharya from IIT Mumbai, and sorry, I must close this. Just a second. Escape, yes, and I move. This is my Jabra database. This is one of my favorite papers.
Radar vegetation index for crop monitoring using the impact. Is that, sir?
Using SAR for agriculture. So if you want to do something which is relevant for this region, and compact SAR is also an interesting technique. But if you want to do something which is relevant for this area, how about studying the phenology of rice paddies from SAR? And you can do it. We did something like that. But I cannot do. And these people are here in India. Professor Avik Bhattacharya, besides being a very good friend of mine, he's a fantastic person. Rice phenology mapping. So what we do is we get areas here in India. We see that we see the phenology of the rice. So we see that different growth stages look different because SAR will. Sorry, it's difficult to. So we see that different stages should appear different in a SAR image. We do all the mathematical statistical analysis, and with this we can make maps of rise at different stages, which is extremely relevant here. Another application that seems relevant for this region is flooding. SAR is extremely sensitive to moist, so you can map flooded areas by day, night, whatever. Just two of the many applications you can do with SAR. Many, many applications. If you want, I can put you in touch with Professor Abig, or I can give you some of the references. Okay?
Thank you, sir. Sir, one more question. So what type of statistical analysis which gives a significant result with this SAR data, sir?
Ooh,
because
you corner me. Yeah.
basically when we go for this type of applications, we have to give the proof with the statistical analysis so that we can say that our model gives a significant result.
Wow. Essentially, there are two classical ways of doing that, or three. First, just empirical. I look at the image, I know that this area in the field is rice that is just starting to grow, and I do this visual mapping. The second way, which is pretty advanced, I understand the physics of how electromagnetic waves interact with rice, with growing rice. For instance, if there is just water, the electromagnetic wave will hit and go away, black. If the rice starts to appear, then it will start giving me brighter areas and so on. So I must understand the physics of the electromagnetic waves and rice. More advanced, physics plus statistics. But it's not impossible, it's doable, provided you work with a team. That's important, having a team, because you need somebody that goes to the rice paddy field, and you need somebody that downloads the images. So if you want to work with that, yes, start small, start understanding what's going on, and grow and build a team.
Thank you, sir.
Pleasure. So I see there's a question, probably the last one, because I see my guest, I see my host standing.
Good afternoon, Professor. This is Chandramouli from Central University. In general, I learned like SAR images have speckle noise.
Yes.
But your images, the speckle has been removed and showed, or yeah?
No. Wonderful question. Thank you very much. Many people work in the line of de-speckling before using the images.
Yeah.
I have worked a lot in de-speckling techniques, including artificial intelligence. Is that right? But I stopped there because I think that a de-speckled image is useful, has interesting visual properties, but I like much more the original thing, the original beast, the noisy image, because speckle is not, it doesn't show here, speckle is not noise. Remember the exponential with mean mu? What's the noise there? It's not noise. That is the observation. The observation which is noisy gives you information. So most of my work consists of do not combat speckle. Use the data as you get it and extract from them the information that you want, right?
Okay.
But if you want to see images, if you want to make color compositions, yes, do these speckled images.
And if you permit, I have a couple of questions more. How do these SAR images from hyperspectral images, where we have a set of hyperspectral images making it as a cube and work? So do the Salis entropy and other formations apply there?
Oh, very good question. When you get a hyperspectral image, you get for each pixel, say, 250 measurements.
Yes.
Measurements, right?
Yes.
Each measurement corresponds to a very narrow spectral window, and the windows are ideally separated. So mark my word, 250 measurements. In a fully polarimetric image, which is the most complete measurement that we can have, we have 3 intensities, and we have 3 complex correlations. So we have 3 times 6, or 3 plus 6 components. We have 9 components, measurements. But we can add layers of derived features. For instance, Sallis entropy, Remy entropy, Shannon entropy, other measures of texture. We can add other layers of information. They are not measurements, they are features, right? And then we can make a cube. I haven't worked with this viewpoint. It sounds fascinating.
And one last question. You said that you don't estimate the parameter alpha. Why?
Alpha is at the core, at the essence of the G-naught model. It is what differentiates the G-naught model from the gamma model. When alpha, the way I parameterize it, alpha is negative. When alpha is minus infinite, the G-naught model is the gamma model. They coincide asymptotically. When does it happen? When you have infinitely many backscatterers. When the absolute value of alpha is infinite. So alpha, in that case, measures the number of backscatterers, infinite. When alpha starts to approach 0, the G-naught model becomes more and more different from the gamma model. And you can quantify it. It will require a whiteboard and a couple of hours, but how do we do this? We remember mu? I took it away, and I said it will become a random variable. This mu becomes an inverse Gaussian random variable with mean absolute value of alpha. This mean counts the number of backscatterers. If there are infinitely many, the inverse Gaussian distribution becomes a delta Kronecker, becomes a constant, the mu. If it's not infinite, it has variability, but in mean, it tells me the number, in mean, in average, the number of elementary backscatterers. We have used it over forest in the Amazon forest. It measures, it's fantastic. It's fantastic.
Thank you, Professor. I have a couple, but I can ask in person later.
Okay, wonderful.
Thank you.
My pleasure. You are my host. You control my time. Okay.
Thank you, sir. Thank you for taking the time to share your insights with us today. Your session was truly informative and inspiring, and we deeply appreciate your expertise and valuable guidance. And thank you for patience in addressing all the queries. Thank you, sir. Now I request Dr. Venkatesan, Associate Professor, HOD, Department of CSE, and Dr. Narendran Rajagopalan, Professor, Department of CSE, to facilitate the chief guest with the gift as a token of love and honor. I now request all the faculty members to the dais for the photo session. I now request all the CEC scholars to come to the dais for the photo session.
I'll remove this, sir. I'll remove this. Bag is it? Bag is it? Sir, bag. Look, bag is it? I'll do the charger also. Come, bro. Sir.
Elephant. Shall we start, sir? Okay. Now we will move on to our next keynote session. It's my pleasure to introduce today's distinguished guest, Professor Arun Kumar Sangaya, a highly accomplished scholar, an internationally recognized researcher in the fields of artificial intelligence, Internet of Things, and sustainable computing. Professor Sangaya is currently a distinguished professor at the International Graduate School of Artificial Intelligence, National Yunlin University of Science and Technology, Taiwan. He earned his PhD from VIT University, India in 2014 and brings with him more than 20 years of rich academic and research experience. Before joining UNTEC, he served in various capacities from lecturer to professor at VIT University from nearly 2 decades. His research contributions are extraordinary. Professor Sangaya has published over 300 research articles, edited more than 11 books, and holds a filed patent. His remarkable work has earned him global recognition as a Clarivate highly cited researcher for 3 consecutive years, 2021, 22, and 23. He is also a proud recipient of the prestigious Yushan Young Scholar Award, one of Taiwan's highest academic honors. In addition to his research achievements, he plays influential roles in the global scholarly community. He serves as editor-in-chief of prominent book series in sustainable computing and edge AI, and as an editor or associate editor for several well-regarded international journals. His international exposure includes visiting scientists and researcher positions at leading institutions in China and France, reflecting his strong global collaborations. Today, we are privileged to have with us a leader in AI and emerging technologies, a prolific researcher, and an inspiring academician to deliver a talk that is sure to enrich our understanding of current and future research directions. Please join me in warmly welcoming Professor Arun Kumar Sangaya to deliver his invited talk. Welcome, sir.
Good afternoon. I think this session is too difficult for me because of the lunch session. Of course, like Professor has covered the most of the concept, and where my talk is complete differ from his direction because of I'm going to talk about the applications. So, thank you. The chair is giving me the opportunities to give a keynote talk on AI and as well as IoT resilience for specifically, I'm going to talk about smart agriculture and biomass system. And this is our ongoing project supported by Ministry of Science and Technology. And this project is for 3 years. Right now, we wanted to develop how the AI and as well as IoT to be integrated to be a part of addressing the various, kind of more emphasized towards, biomass and as well as precision agriculture. As you know, why I took this topic, you might be like every day you might be heard about there is earthquakes in Taiwan, and also there are a lot of natural disasters in Taiwan and a lot of floods, because this, the government wanted the academic researchers to address the problem more relevant to the social context. At the same time, this project is emphasized towards some of the resilience aspect. So something is happened like how our technology will be helpful to manage the overall complexity, kind of the resilience aspects. So this is the overall outcome of today's talk. So I'm going to talk about why I'm integrating and how this is applicable towards smart agriculture system, at the same time biomass and bioenergy systems, and what are the global landscape surveys and challenges. These are all I'm going to talk about today. So as I told you, so this is our ongoing project, is supported by NSTC, Ministry of Science and Technology. Is specifically what we are doing right now. So this project, we are considering the spatial and as well as temporal data, and of course we also integrating, trying to deploying the sensors in the respective field for collecting the real-time data. At the same time, we also wanted to automating the process towards kind of spatial and as well as temporal data. So both can be integrated. One way, we try to use the IoT for collecting the data in a real time, and another way we wanted to use the AI for doing the automation, because of once the data is being collected, how the AI is going to be a major role. At the same time, we also wanted to address AI in the edge, IoT in the edge. So we wanted to build some kind of smart devices, how those devices will be helpful for the local farmers and other people who has really wanted to use our technology, because of government is expecting that we want to work with the industry very closely and at the same time try to build some kind of products. So now this project is more emphasized towards the biomass and as well as bioenergy aspect in a vegetation landscapes. So as you know, there are global environmental challenges, say like your climate change, extremely changing, and of course it will be affecting our overall people's safety, and as well as there are several extreme weathers because of the environmental aspect. And we expect that kind of food demand, so it is projected that 60% in 2050, so maybe we expecting that. And also the energy demand, because of the technologies keep increases, market is advances, again there is a need of energy usage is quite increasing. At the same time, the government is expecting that something like a more the renewable energy. So because of in Taiwan, there are a lot of agricultural wastages and food wastages, how those wastages being recirculated, reused in terms of creating the biomass and as well as bioenergy. So this is what we wanted to address towards the agricultural wastages and as well as biomass wastages, and significantly contributing to the pollution of the respective land. And of course, we are talking about the industry wastage, Also, we are talking about the host land wastages. So there are several ways how it is being recirculated and to create certain level of energy. This is what we try to address in our project. So what is actually a sustainable and as well as resilient environment? So as you know, as I pointed out earlier, in Taiwan there are a lot of natural disasters used to happen. So something like the earthquakes are used to happen. Even we used to face once in a week, or it's quite common. But the government is expecting that how they try to increasing the level of technology, something like the early warning systems or a kind of dashboards and other APP based systems, how it will be really helpful to the people is going to get to know about the technology and get to accessing the different level of data. So this is what kind of how we wanted to integrate AI and as well as IoT as a part of the resilient environment, where we are talking about one way is sustainable computing. The sustainable computing is generally like how the different computing paradigms, say like AI and IoT, everything has been integrated together, and to address something like various societal problems, say smart agriculture or smart healthcare and energy aspect. So majorly the integration is happening because of we wanted to making the societal based applications, how those applications will be really impact to the people. So that is the reason why we wanted to integrate AI and as well as IoT, and we wanted to automating the various process. So automation we are doing at the same time, the AI based automation and IoT based automation we are doing. One way we wanted to ensure sustainable, everything is sustainable in nature, and another way we are talking about the resilience. So the resilience, again we are talking about how it is helpful to recover some level of threats or natural disasters and other stuff. Say it may be like kind of the various societal areas. And other aspect why we need to combine actually. What is the reason we want to combine AI and as well as IoT? Without AI and IoT, maybe there is the process is slow and the error prone, or maybe the late detection. So the ultimate aim is to be like AI and as well as IoT maybe integrated together to have a early warning systems and early predictive systems. So something like early detection and as well as forecasting and optimization and other stuff. But right now we emphasize towards smart agriculture. So something like a smart irrigation or a precision agriculture or a biomass efficiency. So these are all the area we are addressing our problem right now. So one of the major thing is like how the smart agriculture and biomass will be the circular link. Say for an example, the paddy land or a farm land is creating a lot of wastages, and how those wastages being converted for generating the biomass energy. Something like how it is being reused. The crops or agriculture paddy land can be create a lot of wastages, and how it may be residues the less wastage, and how those wastage will be converted into some level of energy being generated. So this is the major aim of our circular link. So maybe I have a questions here. If the sensor is detected for soil dryness, and what should happen automatically actually? So even we can say alert the farmers, or smart irrigation, or predicting the water need, or optimization, or all the above. Which one you are talking about? It is about all the above, because of it can be of alerting the farmer, or it can be of smart irrigation, of course, like predicting the water need well in advance. So these are all the aspects we wanted to enhance. The sensor is trying to detect the soil dryness. Of course, like we wanted to focus on all the aspects. So IoT in the environmental systems, like we are talking about a lot of low-cost sensors. You might be like Taiwan is hub of IC building, like building of sensors and getting sensors is in low cost. So the government is encouraging to build a lot of low-cost devices, which will be implemented in a lot of paddy land and other kind of applications. Of course, like what purpose we wanted to use the sensors, like in the environmental, sensor is being implemented or deployed in order to collect some kind of level of data. And then once the data is taken back, and how far our network layer and how far our process layer is majorly come into the real value of our application, it's a big question. And what for we wanted to automate and what kind of output we are expecting. Either it may be the dashboard, or either it may be the APP based system, or what kind of output we are expecting from the IoT based environmental system. Again, we wanted to focus towards our IoT in the environmental systems. And the major role, like why we wanted to use AI, again, right now everyone, various applications, without AI we cannot do anything. And again, the AI and as well as IoT can be integrated together. We wanted to focus something like the predictions specifically for smart agriculture and biomass estimation, something like a crop yield prediction, irrigation demands, or biogas output. Again, we wanted to use AI for predictive analytics. At the same time, like we also wanted to classify the different kind of aspects. Using the AI, we have a freedom of using the classification of the diseases, in the paddy land, like there are different kind of diseases is happening. How do we automating the process? Right now, we do have one project is something under the drones, how the drones can be detecting the respective image, and how the drones itself, we wanted to classify the different level of image classification. It's successfully we have implemented and good level of enhancements which we have carried out in our yellow object detection model. And subsequently, like there were various optimization, like how do we use the AI-based algorithm to try to optimizing the process, and something like anomaly detection, trying to predicting the different anomaly patterns. So all part of using the AI as a part of our IoT systems. So you might be like why how the AI-driven IoT architecture is being built, because of you can see in a real-time environment where the sensor is being deployed to collect the data. And once the sensor is collecting the data, again, we wanted to use our AI in terms of AI in the edge, or maybe AI in the fog, or AI in the cloud. It's different aspect according to our scalability of our problem. We wanted to, integrating the AI as a part of our IoT-driven architecture. So here, majorly, we wanted to integrate the AI devices and, of course, the AI algorithms and IoT devices being integrated. Once the IoT devices collecting the data and the AI algorithms coming into the picture, and how do we automating the process, something like a smart automation, how do we doing it, and the data-driven solutions, how we are going to given to the farmers, again, we are majorly emphasizing in our project. So this is something like everybody might be know, like what is the differences between edge and fog and as well as cloud. And the majorly, like the edge is like a device centric, whereas a fog is the intermediate, and whereas cloud is like handling the huge amount of data and over the internet, and even remote and scalable. We are all know about it. And you can see the data pipeline from sensors, how the decision is going to happen. So like how the sensors is majorly for making a role in the data collection, and the pre-processing, again, the AI role is coming into the picture, and feature extraction, again, AI role is coming to the picture. But the modeling, again, the AI modeling, again, our predictive analytics, how we wanted, what kind of objective, why we want to address our AI problem. And finally, like the dashboards and APP-based and other enabling devices and automating the actions we wanted to address with respect to our data pipelining process. So there are type of AI models, say for an example, in the agriculture field, we talking about yield prediction, and disease detection, and irrigation scheduling, and biogas yield, and boiler optimization. So there are different model examples, AI model we want to deploy, or we want to enhance with respect to the different application point of view. So when we are talking about the smart agriculture, like we are trying to integrate IoT, AI, and as well as robotics for the effective data analytics in the farming. And where we are talking about Industry 4.0, Industry 5.0, And subsequently, like we are talking about how this technology is really making a bigger role in such evaluations. So right now we are talking about agriculture 4.0. So something like a data-driven decisions, how we are going to take in the smart devices itself, edge devices itself. At the same time, we ensure that right input and of course right place, right time, and how those technology will be really impact towards to, for say for example, smart irrigation means like how do we reducing the water or fertilizers and labors. Of course, our ultimate aim is to be reducing the amount of manpower, and automating the process is the major goal. So there are smart forms towards the IoT setup, like we have a field sensors, and we have imaging devices, and we have a controllers and connectivity and platforms. So say when we are talking about AI talks for our smart agriculture, majorly we are addressing towards yield predictions, and based on the multiple year weather and soil and management data, we are trying to address the yield predictions. Of course, like this is detection, as I told you, one of the project which we have done earlier, something like the drones can be fly in the paddy land, how it can be detecting the image and how the image is being classified, say like a blister blight or bacterial blight, how it is being classified and how it is being reported to the farmers, and how what kind of early warning system will be given to the farmers. That is what we have addressed in our previous project. Of course, like smart irrigation, so the government is expecting that more or less automating the process, and how reducing the amount of water. It's again one of the area we are focusing on. And fertilizer optimization, we don't have any resources or experts is available, but other models we enhancing towards either image processing aspect or in a time series data, because of the data is being keep collecting from the sensors, and dynamically we are going to handling our automating process. So one of the major interesting case study, say for an example from the Netherlands, like even though there are small lands, but how they effectively using AI and as well as IoT for handling the various aspects, something like the green energy or green agriculture, smart agriculture, or smart energy meters. So there are various aspects how the AI is trying to optimizing the yield. Of course, like high yields in the small area, how we try to reducing the resources. It's most important thing. And other case studies from Israel, like the drip irrigation, again how we try to reducing the amount of water, how the AI and as well as IoT is being integrated to reducing the amount of water is we wanted to use. Something like a drip and sprinkler systems achieving more than 80% of water use efficiency. At the same time, how AI and IoT system is being integrated, and we can able to forecasting the demand of the water we can address. Of course, like sensors and water forecast driving the irrigation decisions are all part of this case study we wanted to address here. Of course, there are other case studies like how this technology is being used. Say one of the tool is like AutoSteer is used to have trying to finding out the respective area we want to cultivate, the acre we want to cultivate. At the same time, we wanted to ensure the efficiency of the overlap at the same time for input usage. So all the case study I want to address here. And other case study, something like more kind of how the smart agricultural markets snapshot, something I wanted to reveal here. Maybe smart agriculture market, right now it's 18.7 billion. We expect that 37.1 in 2023, that is cumulative percentage is increasing more than 80%. At the same time, IoT in agriculture, maybe expecting that it goes above 50 billion in 2030. At the same time, IoT connectivity can be kind of food productions, it goes up to 350 billion. So this is why I am revealing here the usage of IoT and AI technologies keep increasing, and the usage is moving ahead. So right now we trying to address some of the dashboards as I talking about, the biomass and as well as bioenergy system. So right now our objective is to one layer is about the data collection layer, and another layer is we are talking about the application layer. In the application layer, our ultimate aim is to try to build some level of dashboards to display our live data, how it will be helpful for the people, like different area, like say smart agriculture or a biomass system, how this recommendation will be really helpful for the people in order to take some level of decision. So again, we are talking about the decision support systems and other stuff we wanted to address through our real-time dashboards. So again, our earlier speaker has pointed out satellite imagery, but right now I am not a GIS expert, but where my students are working on some level of GIS part, they try to use some level of spatial and as well as temporal data in order to kind of various level of predictions they are trying to doing it. But my role is generally, I'm using the AI models, suggesting AI models, and of course IoT design. They're all part of my role in the respective project. So algorithms beyond the decisions, like again there are yield predictions. So what kind of algorithms and AI models is integrated, I want to discuss here. So again, one of the thing is, like, if you are a farmer, which technology would you trust first? Maybe the drones and satellite images, or soil sensors in your field, or mobile app with the AI predictions. Of course, you try to use all three and to make an effective decision support system. And the benefits when we are talking about AI-driven smart farming, so smart irrigation and the level of water usage is, we try to reduce more than 70% in many cases. And again, the AI-based irrigation, again, maybe maintaining the yield and saves the water. And the precision guidance, of course, it improves the field efficiency by more than 20%. And optimized inputs, again, fewer chemicals and healthier soils are all major focus when we are talking about AI-driven smart farming. And the limitations, and as well as there are some level of ground challenges, maybe sometimes like high initial cost to be required to try to deploy different kind of sensors to be deployed in the paddy land or respective farmland. And again, the connectivity is one of the major issues. But Taiwan, we don't have any kind of connectivity issues, but where other scalability problem, again, if you want to enhance this problem in a remote area, and again, we are always facing the connectivity issues, and how we wanted to automating, it's again one of the biggest challenge. And the connectivity gaps, say such as the rural area, we can proudly say that Taiwan doesn't have any rural area. It's most of the area we have a lot of technologies being deployed, and of course 5G, we are talking about right now 5G, 6G, like all kind of technology is freely available. Of course, microcontrollers and microchips is completely, we are far ahead to other countries. So data skills gap and concerns, again, privacy aspect, and of course data ownership, again one of the biggest challenges when we are talking about this kind of applications. So, and the Indian region, we are talking about, there are numerous pilot projects the government is encouraging, keep encouraging, say like IoT based workstations, soil and weather workstations, and drone spraying, and of course the AI based applications, how the it will be supporting for the farmers. And of course the government is initiating for digital agriculture adaptations, and these are all in the Indian context. And when we are talking about agriculture, also another application we are addressing towards the biomass. So the biomass, again, the wastages from the food, wastages from the animal, and wastages from the plants, and wastages from the field paddy land or other crop lands keep increasing. And the government is taking initiatives how those wastages being effectively utilized, effectively to use to generate a certain level of energy, say like forestry wastage or animal or food wastage, how it will be converted as the biogas or even something biodiesel and other stuff. And so this is the reason we are trying to address this biomass estimation. So how it is relevant to the biomass for sustainability? Again, I am talking about the sustainability in a people point of view, and how the system is being built and how those system is really impact to the people. Again, this biomass system, how the energy we wanted to predict, and how far the wastage is being converted as the energy, and again the energy is being converted used for the respective farmland. So this is the major circular economy we are focusing on. So again, in the biomass, you may like in Delhi, the air pollution due to the burning of agriculture wastages. It's again, those burning is really making a pollution of air. At the same time, there are other factors also we are facing it. So we want to use like how it is the circular economy, effectively those wastages being converted as the energy, and again it goes to our farmland. So how this IoT again is going to be a major role in biomass supply chain. So again, we wanted to use something like more or less like moisture and other sensors and monitors, and ensures the overall, we wanted to reduce the overall spoilages. So the majorly like this project is we are trying to address biomass quality and as well as prediction. So there are we are also addressing the AI forecasting models for biogas yield. Of course, like ANN and SVR, different type of AI models being deployed, and reinforcement learning also we are addressing, and the majorly like operational uncertainty, and we wanted to maximizing the prediction rate. This is our ultimate aim. So one of the case study why we wanted to address this project, some of the case study is taking us our benchmark, and we want to address. So the case study we are talking about Brazil Bagasse power, like how the sugarcane wastages is being converted and to use as a energy value, and say like into electricity, say like the boiler efficiency, or maybe the emission of maximum renewable energy share. So this is one of the case study. So other case study we are talking about Nordic countries like say Sweden and as well as Denmark, how those wastages is being used for heating of the houses and predicting the heat demand, and of course like boiler outputs. So more than 20, something like the IoT controlled biomass plants trying to reduce 20% gains and improving the overall efficiency. So India and as well as in our Asia, like how those how cow dung wastages being used as a biogas. So maybe in our Indian government is keep emphasizing towards those animal wastages being converted as for the methane leakage or disaster pressure and other stuff, and how the AI forecasting the gas volume and as well as cooking fuel supply are all major area. So biomass plant is dashboard. So right now we are addressing towards the biomass dashboards. It is majorly emphasizing towards we have set some of the KPIs, and according to the KPI we are working on it. But majorly right now we wanted to enhance the AI and as well as IoT to be data-driven decisions, to emphasizing towards AI on the edge, how those smart devices will be real impact to the farmers and other stakeholders. So something like a more other environmental aspects, smart biomass and as well as clean energy and other kind of carbon cycle, so are all major areas we are addressing right now. So another thing is like how, if you had a choose to one funding priority, which project would you pick, like village scale biogas or city district heating or biomass powered farms? Of course, these are all the three areas majorly we wanted to address and kind of biomass predictions. So the overall summary, like how the organic wastage and animal wastage or food wastage being detected, of course how the AI model is making a major role to optimizing the process, and the majorly we address like carbon emission reduction and other stuff we really we are addressing right now, and these are all the overall adaptation overview, how those countries using AI and as a IoT for majorly for smart agriculture and biomass estimations, and also we made a lot of comparison table how the key technologies and of course like inputs and what kind of benefits we are going to get. So are all the technologies, and some market and trends graphs, how the market is growing and how the IoT is making a bigger role for precision agriculture and as well as smart agriculture. We expect that in 2030 the usage of those technology in a high demand. Of course, maybe we expect that a lot of smart devices. We wanted to address more every data on edge. So something like survey findings, and also there are a lot of barriers as I talking about high cost, the limited connectivity, and of course data privacy concerns are all the challenges we are addressing, and the clear productivity gains, of course the extension support are also part of challenges as a part of these applications. So technical and as well as infrastructure challenges, as I told you, like connectivity gaps, it's remote areas, again we are facing these challenges, and the sensor reliability, sometimes whatever the data is being collected, like how far we are reliable on those data, again it's a bigger question, and how far we are calibrating the sensors and how far this kind of trustability is again one of the biggest question. And interoperability, again different vendors have a different devices, and again the devices from different vendors maybe integrating the seamlessly. Also the scalability again is a biggest question. For if it's a smaller scale, it's maybe it's easy for us, but if it's a larger scale, again we face a lot of challenges. So there are human, social and as well as policy challenges, say such as affordability, like a smart APV, again it's how far it is affordable to the people, and the trust and usability, maybe sometimes the farmers may have a black box AI and how they try to get their own experiences. So again there are some kind of challenges, and the training gap, again there are lack of digital literacy. Again the farmers may know the technology, and again ensuring the trust among the farmers, again the biggest challenge. And policy uncertainty, and in Taiwan some policy is different, but India some policy is different. How far we wanted to ensuring some level of compliance, it's again one of the biggest challenges from country to country. And the risk for vending inequality and benefits from only to the large firms, it's again all risk we face on policy challenges and social challenges. And there are a lot of future directions we are talking about right now. Digital twins, how the digital twins being integrated as a part of AI and as well as IoT system to create a virtual environment, again it's one of the future directions we are all focusing on. And the self-learning systems, we are talking about reinforcement learning and other systems we are talking about, and some level of integrative systems such as climate services and anticipatory decisions, and the carbon accounting are all we are addressing, and the edge AI chips, low power device inference systems for resilience are all future directions. But we are talking about the unified framework. One layer we are talking about how far we try to use the sensors to collecting the data, and another layer we are talking about connectivity and as well as edge, what kind of technology or 5G or even some level of gateways, how far the connectivity is going to helpful to from the data layer to our application layer. And the majorly towards the A and as well as analytics part, the different areas such as yield predictions and disease detection or irrigation optimization, gas yield and boiler optimization are all the areas we are addressing in our project. But the major applications right now, our objective is to try to build dashboards and automated control system, and of course the decision support system we want to address as part of our applications. So the conclusion, so right now, how the AI and as well as IoT system can be transforming a different agriculture sector in the next decade, and how we try to use the smart farmings and delivers the high yields, and what kind of environmental benefits we are going to get, and the smart biomass, how the wastages are being converted and to build a low carbon energy and support for a rural development. And the major barriers, as I highlighted, cost, connectivity, skills, and trust are all challenges for us. But inclusive design and local pilot supportive policies will be ensuring every benefits, and again country to country ensuring the compliance are all major challenges we want to address in our current project. And apart from that, there are different applications we want to discuss now, but due to the time limitation, I want to skip now. So this is the ongoing project we want to address towards how we wanted to kind of IoT cloud integrated system. So finally, from this project, we are trying to develop some level of dashboards to the farmers. Okay, so till that I want to conclude due to time limitation. So thank you for listening, and you have any questions, feel free to ask me. Thank you so much.
Hi all, this is Kamaraj. I'm from HCL Technologies. I'm working as a general manager. Okay, just I came here to just accompany my wife. Okay, sir invited. Thanks sir for the wonderful session. Really, I mean, whatever Arun covered is really is very kind of eye-opening for the scholars, especially students. Because industry, we started implementing IoT and whatever Arun talked about, AI, all this, okay? My humble request to the, scholars, more than learning the, Java or other technologies, please try to take this and apply, AI technology or IoT, whatever. I request you to explore more on this and implement. Okay, lot of research happening, I know, but when it comes to implementation, it's very less. Okay, compare with the, whatever the research you are doing. So I wish you are all take this kind of input and try to implement this, okay? Not only Taiwan, I want to see this in India. Thanks all. Thanks, Arun.
Thank you so much. Actually, in Taiwan, the government is funding to the professor. Generally, they are expecting some level of fruitful outcome. So without outcome, they won't give a funding to the professors actually. Outcome may be either, it may be some level of prototype, or either some level of product, or even some level of dashboards they are expecting. Because of once we got the project, they are directly connecting to the industry, and then really, we keep getting the industry advices, suggestions, and we are moving ahead. Because of we only have a theoretical knowledge how we wanted to deploy these models, but the industry people really, they know how this technology will be helpful, kind of scalability aspect. So we really closely working with the industry. At the same time, government is encouraging the professors, especially I am the foreigner, even the government is given more than a 10 million funding is really, they expect some level of dashboards. Only is focusing these dashboards for the Yunlin County where my university is located. We closely working with the local county government, and we wanted to deploy this dashboard for the Yunlin County. So the application I'm talking about majorly like both smart agriculture, that is yield prediction and biomass, how it's both can be integrated, and how the energy is being, to measured through various spatial and temporal processing. Of course, like one part we try to enhancing the AI role, and another part we also deploying the IoT sensors in the real time. We also connect our automating process through our spatial temporal data. Yeah. Thank you. Yeah, thank you. Thank you so much. Thank you.
We extend our sincere.
Yeah, you have a question.
Oh, okay.
Professor Arun, thank you very much. And more than a question, it's a tease, it's a provocation. When you presented the challenges, I immediately saw the abilities of certain non-profit organization called university. So do you know of initiatives in which universities make like a spin-off that solves all these problems? Because different departments at this university so they have the ability to solve those problems. So how are integrated universities in this system, this ecosystem?
Yeah, thank you, Professor, for asking this question. Actually, the government is given funding to the university professors, to carry out this research and innovate some new technology. Once this technology is really, more interesting or more keen towards the scalability aspect, they directly connect with our local government. Of course, they encouraging to work with the industry very closely and trying to convert some level of small prototype into a bigger product. So the government do not encourage to do given funding to the professors, quite simply. No, they really expecting some level of outcome, in a fruitful outcome in terms of at least prototype they are expecting. If we do not produce any kind of prototype, next time the government don't give any funding to me, they majorly, they set some level of KPI, what KPI you want to address from this project, what sustainable goal you want to address this project. The SDG, the government is majorly emphasizing on various sustainable development goals, say like a clean energy or a clean water, as you are talking about what SDG is going to address. Directly they are mapping the technology with the SDG. So without mapping the SDG, like we cannot go with the certain level of applications. So they are trying to emphasize, the government is encouraging the professors to do the smaller scale research to innovate some level of technology, and those technologies really more interactive, and then they want to migrate from small level into larger level. This is what the government is doing actually. So because of government have a lot of funding encouraging the academic research, as he pointed out, industry-based research also is bridging the gap. Actually, now they are trying to bridging the gaps between academic research and as well as industrial research. But again, the AI, we have a freedom to deploy in different areas actually. Yeah. Thank you.
Thank you, sir. We extend our sincere gratitude for your enlightening guest lecture. Your knowledge and thoughtful explanations added immense value to our learning. It was a wonderful interactive session. Thank you for inspiring us with your expertise. Now I request Dr. Venkatesan, Associate Professor HOD, Department of CSE, and Dr. Narendran Rajagopalan, Professor, Department of CSE, to facilitate the chief guest with a gift. We offer the gift as a symbol of our gratitude, honor, and affection. Short announcement. We can have the track session in the respective venue after the lunch break. Thank you all. Okay, you can have the lunch in the guest house, first floor. Thank you.